Welcome to the video. Today we are going to dive into a fascinating problem that many programmers encounter while measuring the impact of branch misprediction. The problem arises when trying to assess the performance difference between processing a sorted array versus an unsorted one. Despite expectations, there seems to be no penalty for branch misprediction at all in this case. We will explore why this happens and where the benefit of branch prediction goes missing. In the solution provided, we discovered that GCC, MSVC, and Clang all generate a branchless assembly code in the scenario. This means that there are actually no branches present in the code, leading to the absence of any impact due to branch prediction. GCC specifically employs SIMD instructions like cmovge and PCMP-GDD to compare items in blocks of the array and effectively count the numbers above 5 without the need for traditional branching mechanisms. Continuing with the solution, MSVC takes a similar approach but replaces SIMD instructions with cmovge, a conditional move instruction. This ensures that the code remains branchless and efficiently counts the desired numbers. By eliminating branches, the code execution becomes more streamlined and optimized for performance, resulting in consistent results regardless of array sorting. Moving on to Clang's solution, we observe a similar branch-less pattern utilizing SIMD instructions and unrolling the loop 4 times for enhanced efficiency. By directly comparing and processing blocks of items without branching, Clang achieves a high level of performance optimization, further emphasizing the negligible impact of branch prediction in this context. In summary, the lack of penalty for branch misprediction in processing sorted and unsorted arrays stems from the clever optimization techniques employed by GCC, MSVC, and Clang. The generation of branch-less assembly code utilizing SIMD instructions and conditional moves ensures efficient execution and consistent results, ultimately nullifying the expected impact of branch prediction. Thank you for watching, and remember to like, subscribe, and leave a comment below.